Testing, 1, 2, 3. I am going to show some, I'm working backwards kind of through the display and the transformations. I thought I'd start with the end here and show the power kind of going in here, playing with the compound, the split, the what transformations matrices really are. And then I threw in a little grouping and just for fun, merge group and split group. I don't think I did, but just group and ungroup. So what I did was I took a look at a matrices and I tried to figure out what exactly is this? Like what is coming out of this thing? Why is it a 4x4 matrices? And why is it doing all these wonderful things like scaling 1D? This one's, what's it doing? It's moving a whole bunch of different things. I think this is a great way to start reading a document. Just bring this in here and say, okay, well, what was going on there? And now we've got to rotate minus 90 degrees about the z-axis. So these are nice little boxes that tell you an awful lot, and of course a lot of transformation tools. If you take a look just here, basically all of those produce this kind of geometry, but then tell you it's producing a transformation. And so what is that transformation doing? It's telling you exactly what it is, and you can look at it and see it as a 4x4 transformation matrices. Now, I'm not sure if you remember back in grade 12 math or finite math and why you would use this, but what I did was I just produced a cone, and then with that cone, I simply started to do things like mirroring it. Of course, you don't see anything in the mirror, but you can see what's happening in the identity matrix. Ones down the diagonals and zeros everywhere else. You can see that there's a negative thrown on this top one, and so you're left with that geometry as it's actually mirrored against a plane. I think the plane is actually the YZ plane. You could change that, and you can pull that in anything you want. But I thought I'd look at the move matrices instead of mirroring. So let's just move it in a bunch of directions. You can see here I have it parametrically scaled so I can move it out wherever I want. And what's happening with that is you get the same matrices every time, no matter what you're doing, but you're getting the multiplier over here in the fourth column and the third row. So if it's 2 and then I decide to jack that up to 10, you can see that then they're very far apart. And the matrices is reading at 10 here. Otherwise, everything else stays the same on that. And of course, this is very key for understanding how to code and script and play with what you end up doing if you go into the Python and the C nodes. So this is just great visualization tools. Of course, move away from is going to produce a transformation that's very similar. It's just dependent on the emitter and the distance to that. The move to plane depends on the plane, the above and below, and the orient needs a source and then a target. But it's basically going to do the same thing. It's kind of moving, and then you can take a look at how it influences that matrices. And I'm just pulling out what it does so I can read what's happening. And then I'm going into this compound and saying, okay, what's happening when I take all those and bring it into the compound? I have a compact transformation of 8 different transformations. And then if I take the fragments, I can look in and see exactly what the fragments are of that. So I just think of these as reading tools. Then I jump down to here to the bottom one, which is thinking of rotate. Rotate throws a -1 on here. Basically, that's going to be the same in rotate 3D, rotate axis, and rotate direction, but it's going to play off of all the other information that directs it. I'm defaulting to the angle, I think, 0.5 pi and plane XY plane. So you can play with that as well. But understand the matrices, kind of see what they do, play with the inverse. So what I did up here was I just grabbed all these geometries that were coming through here, 6 unturned surfaces, grouped them, said there's a group with 6 objects, and then here's one that I thought was interesting, just splitting the group. Group A is this one. Group B is the remaining 5, and of course the indices is where I'm splitting from, so I can roll around and choose whichever one I want. And that's just something I hadn't done geometrically or computationally, but it just gives you an idea. So jumping in there and just having fun, trying to get every node into use, have a simple script that does it, learn, and then also in the process, kind of understanding what's happening through all of these basic Euclidean transformations. You can go in and we'll do the same possibly in analyzing whatever comes out of these if it's a transform matrix. So let's just go into here and grab the blend box. And we'll take a look that we just end up with a twisted box. If we grab this one, we end up with a geometry box morph. And once again, we're not going to see anything with the transformation, so we'll treat those as a totally different morph transformation and see what we can do with those ones in the next video. Pretty simple. Back down to the 5-minute introductory videos to get you thinking differently and understanding things, getting nodes up and running. And good luck to you. Thanks for watching.